Hello everyone, and welcome to this webinar. My name is Joshua Chastain, and I am an applications engineer at LeaderTech. This webinar will explain the enclosure shielding products that LeaderTech manufactures and how they work. LeaderTech is located in Tampa, Florida, and we have been in operation since 1984. We like to think of ourselves as a full-service EMI solutions manufacturer. We specialize in circuit board shielding, enclosure shielding, cable shielding solutions, absorbers, and we also offer a full line of thermal products. We work with all aspects of industry: aerospace, military, defense, telecom, medical, and commercial industries. We have around 130 employees. All of our manufacturing is done at our facility in Tampa, Florida. LeaderTech is a subsidiary of HEICO Corporation, a global aerospace, defense, and electronics company focused on niche markets. Operating for 62 years with two defined segments: flight support and electronic technologies. Our enclosure shielding products are designed for specific applications. Finding the right one starts with determining the application. EMI RFI gaskets are fundamentally used to create an electrical seal between two surfaces: doors to enclosures, joints between faces, grounding, etc. All of our gasketing options perform this function. Now, the most important question is, what is the application? You can use two classes to further separate our enclosure shielding products and get closer to finding the right one for your application. One, there is mechanical, high-cycle applications where a door is frequently accessed, being open and shut, a gap that can vary in size with the opening and closing, and wiping applications, to name a few. And two, there is low-cycle and/or environmental seals. These doors or compartments are rarely or infrequently accessed, and these can also offer protection from fluids, dust, or moisture. This slide shows the two classes and the enclosure shielding products we offer for each. For high cycle applications, we offer FSG, which is an acronym for Fabric Shielding Gasket, and beryllium copper fingerstock. For low cycle applications that also offer an environmental seal, we offer knitted wire mesh combo gaskets, oriented wire, and conductive elastomer products. For low cycle and non-environmental needs, the FSG fabric shielding gasket, knitted wire mesh, and conductive foam products work. For the next few slides, I will focus on the two high cycle enclosure shielding products: fabric shielding gaskets and beryllium copper fingerstock. Beryllium copper fingerstock is made from beryllium copper sheet metal, formed to the desired shape and heat treated to maximize the strength of the material. Choose beryllium copper when significant dynamic range is desired, wiping or shear forces are part of the application, or if the gasket must withstand a high number of cycles. FSG is extruded polyurethane foam with conductive copper nickel fabric wrapped around it. FSG gaskets are a more economical option than beryllium copper and are simply applied with a pressure-sensitive adhesive where you need them. Beryllium copper alloy is composed of 0.5% to 3% beryllium and is non-magnetic. It is used a lot for high reliability contacts and springs. We offer a variety of shapes and offer some extreme low-profile options like the one pictured here. You can see a profile view or side view of a shape in 4 different stages of compression. There's the initial stage with no contact, the minimum recommended compression, nominal compression, and then the maximum recommended compression. We have named some of the series of fingerstock according to their mounting method, and some have been named according to their design. There's slot mount, which clips into slots or slides onto mounted tracks. The folded series offers a large range of deflection and compression forces and are available with or without tape for alternate attachment methods. It's also available in a snag-free version where, under compression, the leading edge of the gasket slides into an extended and folded base, which prevents possible damage to the gasket. You can see that here. Compact PCI gaskets are designed for easy card insertion in rack mount applications. And the Twist series gaskets are designed for demanding compression applications. This series can compress to material thickness and is also available with or without pressure-sensitive adhesive. The list you see here is our standard plating options and their finish code for our part numbering system. The plating provides corrosion resistance for the fingerstock and, depending on your application, allows the beryllium copper fingerstock to mate with the other metal surfaces in your application. Our standard option is an unplated bright finish. You can see the letter code BD. We have many standard sizes and shapes available for our fabric shielding gaskets, and they are easily customized as well. We can make new sizes to the standard shapes and can also accommodate custom shapes to fit your application. The material can be die cut and laser cut, as you see here, and is great for custom I/O panels. We recommend them for frequency ranges from 20 MHz to 10 GHz, operating temperatures from -40 to 158 Fahrenheit, and have measured shielding effectiveness from 80 to 115 decibels. The material has passed a flammability rating of UL 94-V0, and it is available with or without conductive or non-conductive PSAs. Switching over to low cycle and non-environmental applications, I will focus on knitted wire mesh and conductive products for the next few slides. Our conductive foam material is composed of resilient nickel-copper polyurethane foam layered between two pieces of conductive polyester fabric. This material is manufactured in sheets, and we can further die cut and laser cut the material to meet the needs of your application. This makes it also great for I/O panels. The target application is frequency ranges from 10 MHz to 3 GHz, operating temperatures of -40 degrees Fahrenheit to 150 degrees Fahrenheit, and can also provide an average shielding effectiveness of 60 decibels. We recommend 30% compression of the material and is standard with or without conductive adhesive. Knitted wire mesh gaskets consist of many interlocking loops that act as small springs which provide for a resilient, all-metal conductive gasket with high attenuation characteristics. It can provide shielding effectiveness up to 130 decibels in the E field and up to 80 decibels in the H field. The standard wire materials are tin-plated copper-clad steel, Monel, and aluminum in cross-sections of rectangular, round, round with fin, and double round with fin. All cross-sections are available in both all mesh or elastomer core configurations. If your application requires an environmental seal, these next slides will describe conductive elastomers, knitted wire mesh combo gaskets, and oriented wire. LeaderTech's conductive elastomers are made from 2 polymer bases and are mixed with 6 different metallic fillers. Both the silicone and fluorosilicone polymer bases offer shelf lives up to 20 years. Fluorosilicone differs from silicone because it contains trifluoropropyl groups, making it highly versatile for outdoor sealing applications or environments where exposure to sunlight, ozone, chlorination, or aromatic hydrocarbons is common. With the polymer bases, we use 6 conductive fillers to make 11 MIL-DTL 83528 certified materials, and some compounds outside of the military spec. MIL-DTL 83528 is a U.S. military detail specification for design requirements of conductive elastomers, such as the material, the performance of the material or part, and the limitations of the material or part. The scope of the specification says, this specification establishes the general requirements for electrically conductive elastomeric shielding gaskets. These gaskets are intended for use in electromagnetic interference, radio frequency interference, suppression applications. Having conductive elastomer materials approved for manufacture by the U.S. Department of Defense signifies that it has passed the inspections and tests of MIL-DTL-83528. This testing and inspection methods have their own requirements and standards as documented in their corroborating MIL or ASTM testing spec. There is a main specification that details the material compounds and their required characteristics, and 16 further specifications that detail their unique part numbering system, which you can see here, and part numbers, standard shapes, tolerances, sizes, all for extrusions, sheets, flange gaskets, O-rings, and waveguide gaskets. Conductive elastomers are composed of over 65% of the conductive metal filler. We combine the metal filler and polymer base in-house and use it to fit many applications. We mold sheets that can be die cut and laser cut and can extrude to multiple shapes. The extrusion can be bonded to make O-rings and frames. We also compression mold O-rings, frames, and waveguide gaskets. Mounting the conductive elastomer will depend on the shape and your application. As you see here, we recommend a specific deflection compression for every shape of the material, so it will be effective in the application. For grooves, a friction fit is recommended if possible, and at full compression, we recommend a maximum of 97% fill of the gasket in the groove. Rivets, bolts, spot bonding, and PSA are other ways to mount. Non-conductive adhesive is recommended for PSA and for spot bonding because conductive adhesives sacrifice adhesion strength with the addition of conductive particles. Knitted wire mesh combo gaskets are comprised of Monel or tin-plated copper-clad steel knitted wire mesh, which is then bonded to neoprene sponge, silicone or solid silicone elastomer strips. They are cost-effective for low cycling applications, provide high shielding effectiveness over a broad frequency range. The knitted wire construction provides long-lasting resiliency, and the combination with elastomer offers protection against moisture and/or dust. Oriented wire gasketing is constructed of Monel or aluminum wire oriented perpendicular to the mating surfaces and embedded in solid or sponge silicone elastomer. The wires create an electrical connection between the mating surfaces as well as create an environmental seal. They are only conductive in one axis, along the wire. The wire is crimped for additional resiliency and to optimize the mechanical performance of the gasket. It has between 700 to 900 wires per square inch. The material is available in strip or sheet form and can easily be die cut or laser cut into complex shapes or fabricated into custom frame gaskets. To alleviate electromagnetic interference and also make electrical contact, two metals need to mate. If those mated metals are contacted with a corrosive electrolyte such as water, galvanic corrosion can occur. A galvanic compatibility chart is a good tool to help decide the plating, wire, metal, or filler that may work best for your application. The electrochemical voltage between that metal and gold can predict the compatibility of metals. This is called the anodic index of the metal. The chart shown here lists 38 groups of metal with an anodic index voltage. For harsh environments like outdoors or high humidity, it is recommended that the difference between the metals not be more than 0.1 volts maximum. For example, nickel is 0.3 volts and beryllium copper is 0.35 volts. Their difference is 0.05. These metals are very compatible. For normal conditions, we recommend a max difference of 0.25 volts. This would be something like a warehouse that is not temperature or humidity controlled. And for controlled environments, we recommend a difference of 0.5 volts max. The best prevention for galvanic corrosion protection between the enclosure shielding gasket and mating surface is to choose compatible metals, plating on one or both of the mating surfaces, and controlling the environment from things like humidity or soil. All of our enclosure shielding gaskets require compression. we recommend a compression range for each product line and shape. If the gasket is compressed below the recommended range, it may not provide the intended performance. In the case of conductive elastomers, the material is metal particles with a binder. Those metal particles can only contact one another with compression to create electrical contact. Over-compressing the material can also cause issues. The material can break, and over-compressing conductive elastomers can create separation between the metal particles and reduce conductivity. Compression set and permanent set is also possible, and for some materials may occur within the recommended compression range. Depending on the size, temperature, percentage of compression, and the amount of time compressed, the material may not rebound fully to its original height. This is compression set. For some applications, such as low cycle or permanently closed gaps, the compression set may not affect the application. In conclusion, here are some key points to ponder when trying to determine the best enclosure shielding gasket for your application. What is the operating environment? Is it inside or outside? Is it a high cycle or is it a low cycle application? What materials will the gasket be mating to? How do you require the gasket to mount to your application? Are there space and weight limitations to your application? We appreciate you for taking the time to listen to this webinar. Please let us know if you have any questions.